Center of gravity. Center of gravity. To understand center of gravity, take a body, irregular body, and imagine the body. Imagine the body as though it is composed of several particles, like the particles of mass m1, m2, m3, etc. And the total mass of the body is say capital M. Then each particle will be attracted by the earth towards its center. Towards its center, we can consider the gravitational force of attraction to be parallel on these particles. These gravitational forces can be considered to be parallel forces. Then the entire force, the force due to the entire particles is the vector sum of these particles. So it is written as capital Mg is the total force acting on the body. That will be equal to the total force acting on the body, capital Mg, is equal to m1g1 plus m2g2 plus m3g3 dash 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 dash, where g1, g2, g3, etc. are the acceleration due to gravity, acting on different particles. If g is the acceleration due to gravity at a point where the entire mass is concentrated, then mg is the gravitational force of attraction on the entire body. If you apply a force in the upward direction which is equal to mg, if we apply a force equal to mg at this point, then the body will be in equilibrium state. Such a point in the body is called center of gravity. So the center of gravity depends on acceleration due to gravity. If the acceleration due to gravity acting on the body is different at different positions, the center of gravity will be different than the center of gravity if all the particles are subjected to same gravitational force. If the acceleration due to gravity on the particles is the same, then the center of gravity coincides with center of mass. If acceleration due to gravity is uniform on all the particles. If the acceleration due to gravity is different, then the center of gravity will be different from center of mass. Comparison of center of mass and center of gravity. Center of mass on the left side, center of gravity on the right side. Center of mass is a point where its entire mass appears to be concentrated. Center of gravity is also a point where its entire weight is concentrated. Entire weight of the body is concentrated. Next, second point. Center of mass depends on the distribution of masses. Center of gravity depends on the distribution of weight. Center of mass is independent of acceleration due to gravity. Center of gravity depends on acceleration due to gravity. Center of mass is described. It describes the motion of the body. Center of mass is defined to describe the motion of the body. Center of gravity is defined to know the stability of the body. Center of gravity is defined to know the stability, and center of mass to know the motion of the body. Definition of center of mass. To define the center of mass, let us consider two particles of mass m1 and m2 situated on x-axis at A and B. Let us consider m1 is at A and m2 is at B, both on x-axis. Let us consider a point C in between them such that m1 into AC is equal to m2 into CB. Let us consider a point C in between A and C such that m1 into AC is equal to m2 into CB. m1 into AC is equal to m2 into CB. Such a point C is called center of mass of the two particles m1 and m2. The two particle system m1 and m2. It is the center of mass of the two particles m1 and m2. Relation for center of mass. If we consider AC is equal to d1 and CB is equal to d2, the distance AC is equal to d1 and the distance CB is equal to d2, then by definition m1 into d1 is equal to m2 into d2. m1 into d1 is equal to m2 into d2. We know that AB, the distance between the two particles, is AC plus CB. So it is equal to d1 plus d2. AB is equal to, if you say the distance AB is equal to small d, then d is equal to d1 plus d2. Center of mass in terms of coordinates. Let us consider the coordinate of x coordinate of mass m1 is x1 and the x coordinate of mass m2 is x2. Then OA is x1 and OB is x2. X coordinate of m1 is x1, x coordinate of m2 is x2, then OA is x1 and OB is x2. We have the relation for center of mass m1 into AC is equal to m2 into CB. AC is d1. If we consider the center of mass coordinate as xcm, that is OC is equal to xcm, OC is equal to xcm, and then take the definition of center of mass m1 into AC is equal to m2 into CB. Here AC is d1, CB is d2. Then d1 is equal to xcm minus x1. d1 is equal to xcm minus x1 because AC is equal to OC minus OA. AC is equal to OC minus OA. Similarly, d2 is equal to x2 minus xcm. d2 is equal to x2 minus xcm since CB is equal to OB minus OC. OB is x2, OC is xcm. OA is x1 and OC is xcm. Hence, d1 is xcm minus x1 and d2 is x2 minus xcm. Relation for center of mass. By definition, m1 into AC is equal to m2 into CB. AC is d1, CB is d2. So m1 into d1 is equal to m2 into d2. So d1 is xcm minus x1, d2 is x2 minus xcm. Hence, m1 into d1 is xcm minus x1, d2 is x2 minus xcm. Therefore, m1 into xcm minus x1 is equal to m1 into xcm minus x1 is equal to m2 into x2 minus xcm. m2 into x2 minus xcm. Therefore, by rearranging the terms, we get xcm into m1 plus m2 is equal to m1 x1 plus m2 x2. xcm into m1 plus m2 is equal to m1 x1 plus m2 x2, or xcm is equal to m1 x1 plus m2 x2 whole divided by m1 plus m2. xcm is equal to m1 x1 plus m2 x2 whole divided by m1 plus m2. This is the relation for center of mass. Origin at A. If we choose the origin at A, then its x coordinate becomes 0. So x1 becomes 0. The relation for center of mass is xcm is equal to m1 x1 plus m2 x2 by m1 plus m2. The relation for center of mass is xcm is equal to m1 x1 plus m2 x2 by m1 plus m2. If x1 is equal to 0, then xcm is equal to m1 into 0 plus m2 into d, where d is the total distance between A and B whole divided by m1 plus m2. So xcm is equal to m2d divided by m1 plus m2. xcm is equal to m2d by m1 plus m2. This is the distance from A up to the center of mass. T is the distance AB. distance AB. Origin at B. Origin at B. The relation for XCM is m1 x1 plus m2 x2 by m1 plus m2. The relation for XCM is m1 x1 plus m2 x2 by m1 plus m2. If the origin is chosen at B, then x2 becomes 0. Then x2 becomes 0. Hence, XCM is equal to m1 into D plus m2 into 0. m1 into D plus m2 into 0 whole divided by m1 plus m2, which becomes XCM is equal to m1D by m1 plus m2. m1D by m1 plus m2. Suppose two masses m1 and m2 are at distance D. m1 is at A and m2 is at B. Then if we want the distance of center of mass from A, then we choose origin at A. So its coordinate becomes 0. And the distance of center of mass from A is given by the relation XCM is equal to m2D by m1 plus m2. If we want the distance of center of mass from B, then we choose the origin at B, and the distance of center of mass from B becomes equal to XCM is equal to m1D by m1 plus m2. Center of mass of number of particles. Let us suppose particles of mass m1, m2, m3, etc. lie along x-axis with coordinates x1, x2, x3, dash, dash, dash. Then the center of mass of this system of particles is given by XCM is equal to m1 x1 plus m2 x2 plus m3 x3 plus dash, dash, dash whole divided by m1 plus m2 plus m3 plus dash, dash, dash. This can also be written as XCM is equal to sigma mixi divided by sigma mi. Sigma mixi represents m1 x1 plus m2 x2 plus m3 x3 plus dash, dash, dash. Sigma mi represents m1 plus m2 plus m3 plus dash, dash, dash. In general, it is written as XCM is equal to sigma mixi divided by capital M, where capital M represents the sum of the masses, the total mass of the system, Center of mass of distributed system. We have derived the relation for center of mass as sigma mixi by capital M. This is the relation for center of mass of distributed particles system. If the system is composed of several discrete particles of masses m1, m2, etc., then we take this relation for finding the center of mass. If the mass is distributed, if you take a stick, the mass is distributed along its length. In such a case, the above formula reduces to an integral form. If we consider a small elemental length like dm at a distance x from the origin, consider a small elemental length dm at a distance x from the origin, then the center of mass of the entire system is given by 1 by capital M, where capital M represents the entire mass of the stick or the rod distributed system. 1 by M integral x dm. X is the distance and dm is the mass, small elemental mass at a distance x. We use this integral for finding the center of mass of the distributed system. 1 by m, 1 by capital M integral x dm. This is the relation used for finding the center of mass of distributed system.